Hello, everybody. Good evening, or good morning, or good afternoon, depending on when you're watching this. I am going to go through challenge one from the Little Book of Algorithms by William Lau. Again, I will put the link to his book below here if you haven't got a copy of that. Now, remember that these videos are going to help you prepare for your GCSE. That's whether you're in year 9, perhaps you want to just complete a refresher, seeing as we've spent so much time away from school. Or if you're in year 10, perhaps for the same reason. So we're going to work through these challenges together. We're going to upload these videos regularly. And I'm going to take this approach, which is perhaps different to William Lau's approach he describes in the book. I'm going to use computational thinking as a backdrop to, or a set of tools to solve the problems. Computational thinking is part of the GCSE. It's one of the first topics that you study, and it's there because it feeds into all parts of your programming and how you think about problem solving. So I'm going to start with that. You've studied computational thinking in Key Stage 3 as well, so this won't be new, but what I'm not going to do is I'm not going to just dive straight into solving these problems. You might notice if you've taken a look through the Little Book of Algorithms, William Lau straight away jumps into functions and procedures. I'm going to take a slower introduction, reflecting how we've at Lord Bill's how we've studied computing, and we're going to use computational thinking and to create our algorithm, which in the GCSE is represented by either pseudocode or flowcharts, or ideally both when we're learning. I'm going to use Scratch. Now, we've used Scratch at school. We've had a lot of practice with Scratch. So I'm going to solve the problems in Scratch and use those as my pseudocode, as a pseudocode representation before diving straight in to Python after that. So I've got Spencer here to help me. I do need help with my Python programming. As I was solving these problems earlier on, I was feeling a little rusty. It's been a few weeks. Perhaps that can reassure you if when you're diving into Python now you feel a little rusty. I guess it may have been a few months since you looked at it if you're in year 9. So don't feel bad. I was feeling rusty. Same for everybody. Even I'm sure even the best coders in the world have been away on holiday, come back to it, can't quite remember the different constructs. So let's get started. So computational thinking is made up of these 4 areas. So decomposition, breaking a problem down into smaller, more manageable problems. That's what we're going to focus on really to solve this first challenge 1. Abstraction, removing unnecessary detail so we can really hone in on the problem. We have our pattern recognition, helping us simplify the problem by spotting similarities in it. And William Lau has also he's dived straight in, as I said, using functions. We're not perhaps we're recognizing patterns. We'll do that later on. And then we have algorithms, step-by-step set of instructions to complete a task. I will put these slides on Google. You can see the link below. Okay, so you'll be able to use these. So the first challenge is write a program that has 3 parameters, num1, num2, and num3. The program should take 3 numbers as arguments and return the highest number. Now, if we're decomposing this problem, I saw 3 points there. So use a variable for each of the 3 numbers. We've got 3 separate numbers. We have 3 variables. We've got 3 numbers. These 3 numbers as arguments suggest there's some kind of comparison, greater than or equal to, in there. So that's what I've used. And then we've got some selection. And remember, in Python, selection is represented with if, elif, else. So we're going to use selection to find the solution in our algorithm. So I have my pseudocode. Really, it's pseudocode. I'm going to write Scratch. Now you can't read that, can you? That's far too small. So fortunately, I have Scratch here. You remember Scratch. It's awesome. So we have ask, what is the first number? Then we save that answer to a variable number 1. What is the second number? Save that answer to number 2. What is the third number? Save that answer to number 3 variable. And then we have our comparisons. Now in Scratch, there's not a greater than or equal to. There's a greater than and an equal to. So we need to do with our Boolean logic, we have to say as in greater than or equal to. So we have greater than number 1, greater than number 2, or number 1 is equal to number 2. And, so more Boolean constructs, number 1 is greater than number 2. Let's get rid of that. Oh, what's going on there? I have number 1 greater than number 3, or number 1 is equal to number 3. So that's just expressing greater than or equal to. Then say the highest number is number 1. I mean, really, if we just step through this. So if number 1 is greater than number 2, or equal to number 2, and number 1 is greater than number 3, or number 1 is equal to number 3, then say the highest number is number 1. So in Boolean logic, what this means, and it means this condition has to be true. So number 1 has to be greater than number 2 or equal to number 2, and number 1 has to be greater than or equal to number 3. So this and is, well, if this means if this component is true and this component is true, then number 1 is the highest number. Perhaps there's some getting used to there. We did do some of this in year 9. So have a look at this code and think about it. So then we have another if statement. If number 2 is greater than number 1, greater than or equal to number 1, and number 2 is greater than or equal to number 3, the highest number is number 2. And same with number 3. So if number 3 is greater than or equal to number 1, or greater than or equal to number 2, then number 3 is the greatest number. So this is the logic, specifically Boolean logic, that's been used here. And we can test it as well. So with Scratch, you remember we have the famous green flag. Here we go. Let's make that a little larger so we can see it. What is the first number? 76. What is the second number? 32. What is the third number? 11. The highest number is 76. We can test it too with, if we have 3 numbers very close, so we say 11, 11, and 10. The highest number is 11. We can also test, let's test if we have the same number. 11, 11, 11. The highest number is 11. So what we're doing here is we're testing our algorithm. We're not just writing it, we're testing it as well. And Scratch is quite powerful. We can test it too. Fantastic. So now we have a working algorithm in Scratch. We can now go into Python. And here is something I prepared earlier. Now, both for Scratch, I will share the Scratch code below and the Python code below. Now, the Python code looks a lot cleaner, doesn't it? Just taking a look at it, it's quite simple. Some of this is that perhaps because Python does allow us to have a greater than or equal to that's not as messy. So here, and remember in the book, William Lau uses a function. I'm not diving into functions yet. We haven't studied that in year 9 yet. Well, not yet. We're at the end of year 9 now. So at all, it's not studied in year 9. So I'm going to introduce that later on. Now, this is a refresher on selection and our comparisons. And you'll see here we store, remember we have num1 equals input. What is your first number? Num2. What is your second number? Num3. So we're storing in our variables. And then we have our comparison. So if num1 is greater than or equal to num2 and num1 is greater than or equal to num3, it must mean num1 is the highest number. Elif. Num2 is greater than or equal to num1 and num2 is greater than or equal to num3. The highest number is num2. And we have another elif, num3 comparison with num1. And the and means both sides of these comparisons needs to be true in order for this to be the code below to be ran. And what else is there worth mentioning? Remember we have the indents, we have our colon, and I've also added comments. So with our hashtag, and I've just added a comment what the code is doing. This is an excellent practice to do. So with my year 10s this year, there'll be extra marks in homework for comments, sensible comments, explaining what each block of code does. This not only helps me mark your work, but it also helps you to really step through and explain and articulate and demonstrate to me that you understand what your code is doing. So it's a very good habit to get into. Also later on in life, when if you choose to go into computing as a career and you are writing code, and then you go on holiday or leave a company, and then you don't leave hundreds or thousands of lines of code for someone that's not commented, end up like me with no hair. They will absolutely spend days and weeks trying to understand your code. But if you've added comments in there, fantastic. Cup of coffee, sit down, work through it. Lovely. So it's a very good habit to get into, and your peers will love you. Right. So that's challenge 1. I'm going, as I said, I think I've repeated myself several times, but I want us to get into the habit of this. So we have computational thinking first. We're going to apply, get into that habit. Then I'm going to use Scratch. Bit of practice with Scratch, always a bit of fun as well to draft our algorithm. And then we're going to use Python. So we're not going to jump straight into Python. We're going to take it step by step. Okay, everybody, you take care. And I will be back next week with another exciting challenge. Not just me, Spencer and I. We will be back soon. Okay, take care, everybody. Bye.